Uh, for people who don't know me, my name is Amod Onkar. I'm the country head for India and also the product manager for 3-axis and 5-axis milling solutions. Today is 5th September. Can anybody tell me the relevance of the day today? I don't know about the world. Today is Teachers' Day. So we all have teachers in our lives, right from the time when we are born. We go to school, we have teachers. We go to the college, we have teachers. Even in this room, we have a teacher. Emil, happy Teachers' Day. We have learned a lot from you. Okay, so first of all, what is a unified engine? So there's a story behind it, and I wanted to really tell you a very beautiful story about this, but I did not have any words, so I wrote to Perplexity, which is the AI software, to give me a nice story for the unified engine. It gave me a story that was more relevant of Shakespeare, and I forgot about the story completely. And I think it's better to tell you the truth rather than to tell you some nice story on what and why and what is unified engine. Basically, unified engine is a combination of two components. The turbo toolpath that's already there inside SolidCAM, and there's another engine which is called as a classic engine in ModuleWorks. And the combination of both of these engines together gives us the unified engine. Why was it needed? Well, one day I got a call from ModuleWorks saying that they wanted to discuss the future of turbo. And in one of the meetings, they informed me that they have two teams, one looking after the turbo engine and one looking after the classic engine. And they said that it's becoming very difficult for them to manage both these teams together, and they wanted to focus on one single unified engine, and that's how this unified engine was born. We have been testing this engine for the last 1.5 years, putting it through different what-if scenarios, putting a lot of paths through it, and we have come to a conclusion that it's now cooked and it's ready to release. So we're going to be releasing this pretty soon. So basically, unified is a new generation engine because it combines two big engines of ModuleWorks together to give you a very powerful toolpath generator in 3-axis. It gives you, first of all, the power that was there already in Turbo 3D HSM, and it gives you complete control. If anybody has been working with the Turbo 3D HSR, unified is an extension of Turbo 3D HSR, so it uses the same principle. It offers a very optimized algorithm, improved accuracy. Now, this is one of the things that caught our attention in the last 1.5 years that we have been testing this engine, is the accuracy of this engine is much, much better than the current two engines put together that we have inside SolidCAM. So it's way accurate, gives you a much better surface quality because of the accuracy. Collision-free toolpaths. Now, this is another very crucial thing that was missing in both our legacy HSM as well as turbo HSM, especially when using holders. When we're using holders, it was extremely difficult to find a very good toolpath that would trim the toolpath to the holder and then give you this optimized toolpath for machining. Multi-surface offsets. They give you the possibility to define different offsets on different groups of surface inside finishing in the unified engine. You can also define fixtures, and the fixtures are not taken into account just for the purpose of trimming, but the fixtures are taken into account when it actually starts calculating. So you'll see a big difference. I'm going to show you the difference between our existing Turbo 3D HSM when defined with a fixture and the unified engine when you define it with a fixture. Now, this was something that was a learning for us. We thought that this was already there inside SolidCAM. But both our legacy HSM as well as our Turbo 3D HSM use what we call as 2D trimmer. we take the boundary of the surface, project it to a plane, and then look from the plane and then trim the toolpath. Now, this works very well when you have flat surfaces or near flat surfaces. But the moment the surface becomes more or less steep, the 2D trimmer starts giving problems. So you'll see a lot of retracts coming out because of the 2D trimmer. Whereas in unified, we are doing true 3D trimming. We are not projecting anything. We are just taking the 3D boundary as it is, and then using the 3D boundaries, we are then trimming the toolpath. So it's much more accurate. Boundary definitions are much better inside the unified engine. You can just select either one surface or group of surface, and it generates the boundaries, whether it's a contact point boundary or a tooltip boundary, so it generates it automatically. Most important thing is the arc generation inside the unified engine. I remember a few of our resellers demanding this inside the legacy HSM as well as in the turbo HSM on the arcs. And we could only do XY arcs in turbo 3D HSM, but with the unified, we are able to now generate arcs in any plane. That will need some adjustments in the GPP, but we can now output arcs in any plane. Whether it's XY, YZ, or ZX plane, we can output arcs in anything. Whether you're doing a linear machining, rest machining, constant step over, whatever is the toolpath, you can now generate arcs in those planes. Another very important thing that we have inside turbo, the unified engine, is the feed rate, which keeps automatically adjusting based on the geometry that is being machined. So if you're going in a very tight corner, the feed rate automatically drops to go around that corner much more easily without damaging the tool. So this is a feature inside the unified engine. So what are the strategies that are available? Unified, like I said, is a subset of the turbo 3D HSR. Okay? So obviously, I would consider the turbo or the high-speed turbo roughing as a part of unified engine because the whole thing is one engine. So we have the roughing, rest roughing, hatch roughing, all of them coming in the unified engine now. And of course, in finishing, we have got a host of machining strategies, and I consider geodesic machining to be a part of this. So the geodesic machining, when added to the unified engine, completes the offering that can actually, I can confidently say, can replace our legacy HSM engine. You can totally stop using it, and you can move completely to the unified engine along with the geodesic engine. About improved accuracy, we have seen a substantial difference in the way the toolpath is generated using the unified engine. It respects the tolerances much better than even probably the legacy HSM and turbo HSM. So we get much better results now with the unified engine. We have already seen this by machining few parts, and we could see the difference in the results. Now, another very important thing is the dynamic holder checking. You can look at the left-hand side, that particular part, you can look at the retracts, you can see the retracts. That is because in turbo HSM, or even in our regular HSM, when you define a holder, the holder is the last element that is being checked in the toolpath. Okay? Ideally, that should be the first element to be checked in the toolpath, but that's not happening because most of these toolpath engines are designed to take the holder and check it at the end and then just do the linking. Whereas with the unified, the holder is taken into account while in the calculation stage itself. And using the 3D trimmer, it separates out regions and then links them separately at the end. Therefore, you can see that the toolpath is much clean. It's separated in the region-wise, much cleaner than our regular turbo 3D HSM or the legacy HSM engines put together. Multi-surface offsets allows you to define different offsets for different groups. You can define infinite number of groups, and you can define different stock offsets for that. and it will generate the toolpath in such a way that it will keep those, or it will respect that offset in those regions. Fixture definition, also exactly like how it used to work with the holder. The fixture definition was always applied towards the end. It used to just trim the toolpath and then just link it. But that's not how it works in Unified. In Unified, it is considered to be a part of the geometry. Okay? And considering it to be a part of the geometry, it uses this geometry to develop the toolpath or generate the toolpath by taking the fixture into account right in the very first stage, rather than taking it into the end. Therefore, you see the kind of retracts you get when you use the turbo HSM with fixture and with the Unified engine is completely different. The Unified is much, much clean engine when it comes to the fixture definition. 3D boundaries, like I said, this was a revelation to us because I did not know that we do 2D boundaries only. Our HSM and turbo HSM both take the boundaries, project it to the XY plane, and then use that XY plane as a trimmer to trim the toolpath according to the boundary that was selected. Whereas with Unified, there is no projection. It takes the boundary, the 3D boundary as it is, and trims the toolpath according to the 3D boundary. That's why you'll see that the Unified toolpaths are much more cleaner and represent the surface much better than the turbo toolpaths. Arc fit. Now, something stuck to me, I don't know if you can see it, but actually, turbo 3D HSM is generating more arcs than the Unified engine, okay? Almost 2 times, it generates more arcs. So if, let's say, turbo is generating 9,000 arcs, Unified will generate 4,500 arcs. And this was one of the features that was told to us that it's going to be pretty good at generating arcs. But when I saw that it was generating less number of arcs, we started investigating. I checked with my QA people on why this was happening. And then we realized that Unified generates whole arcs and not pieces of arcs, okay? Whereas turbo generates pieces of arc. Now just imagine that you're machining a hole, just a cylindrical hole. Turbo would generate 3 or 4 arcs on one level, whereas Unified will generate just 1 arc on that level. And that is the reason why it generates less number of arcs when you compare it with the turbo 3D HSM toolpath. Also the number of blocks. Turbo 3D HSM, when compared with the Unified, Unified generates almost 30% lower number of blocks. G-code file is at least 30% lower than the Turbo 3D HSM, or for that matter, HSM G-code. This not only helps you to machine faster, but it gives you a much better surface quality when you actually take this part and go to the machine. We did these trials, and we saw that the arcs were coming very well, both in the XY plane. It came very well in XZ plane, and it also came pretty well in the YZ plane. So it could generate arcs in any plane. So the only catch here is that you need to go back to your GPP. You need to ensure that your GPP is configured to output arcs in any plane given. Another thing was the feed rate control. So Unified now allows you to define ranges of feed rate that it will apply when going in a corner or in a very tight geometry. So if you have defined a feed rate of 2,000, and if you say my minimum feed rate that I would like to apply is 50%, it will ensure that when it goes into a real tight geometry, the feed rate automatically starts dropping till the time it comes to the 50% and then again accelerates in the other region. So this gives you A, much better tool life, B, much better surface quality in the corners. There are other features. Of course, I did not put it. It would have unnecessarily increased the size of my presentation. But there are several other features that are there inside Unified. For the interest of people who would like to check this engine, It's already available in the SP1 release. It's available under the beta options. So you can switch on the beta options, you can switch on the unified engine, and the unified engine will be available for you to test on even real-world parts. It's fully ready. We are just doing the final checks. SP2 is when we are actually going to launch the actual release of the unified engine. Couple of things to note. There are conditions. If your old part, if you're trying to open it in 2023 SP2, when the unified engine will be available, and if your old part does not have any Turbo 3D HSM toolpaths, Turbo 3D HSM will not be seen in the tree. Okay, you'll only see the unified toolpaths. You won't see Turbo 3D HSM. But if your old part has a Turbo 3D HSM toolpath, and you open it in 2023 SP2, you will still see the Turbo 3D HSM toolpaths in the tree. You will also see the unified engine. So you will have you or your customer will have the option of opening either one of these engines and working with it. But if it's a new part or a part that doesn't have any Turbo 3D HSM old toolpaths, it will not be available for the users in 2023 SP2. It'll be completely blacked out, and you will only see the unified engine. So these are the other features that are there currently inside the unified engine, like boundary contract point definition. You can now define boundaries for stock boundaries. You can define boundary for part. Okay, there are two different methods. Machine only vertical walls. So if your part has only vertical walls, you don't have to select anything. You don't have to put any kind of slope angle. You just say machine vertical walls, and it'll only machine all 90-degree walls without any definitions. Another very important thing, people who are coming from the mold and die background, the edge rolling is one of the most critical aspects. Okay, if your current toolpath, our HSM as well as Turbo 3D HSM, don't have any mechanism to prevent edge rolling, so that when you see the toolpath, when it starts, it'll actually start from the sharp corner and then roll down onto the surface. This blunts the sharp corner on the top. Okay? To prevent it, the solution is they'll just extend the surface and start the toolpath way above to prevent the edge from being damaged. But that's going to be taken care by the unified engine just by selecting a small checkbox that says prevent edge rolling. Then we have adaptive step down, cross machining like what we have in the HSM, rest finishing by stock. So you can have rest finishing by previous tool, or you can do rest finishing by previous stock. Both are available. Not roughing, I'm talking about the finishing part. We have independent cutting method. You'll have climb for, let's say, constant Z, and mixed for linear. And the most important thing is we also can now overlap both the toolpaths. Both constant Z and linear can now be overlapped either by a value or by an angle. So these are some of the extra features that are already there in the unified engine. Once you open up the beta, please get in touch with us. You might require a little bit of orientation training, probably a couple of hours, and you'll be good to go. So if I summarize the unified engine, it has collision-free toolpaths because it takes into account the holder geometry, and of course the part geometry is already taken into account. Multi-surface offsets, fixture definition is much, much better now. And of course, we have got 3D boundary definitions that trim the toolpath precisely to the 3D boundary. And efficiency of the toolpath is much better than the Turbo 3D HSM as well as HSM because of the arc fit function that we have introduced inside that can totally reduce the number of blocks that are there in the G code, resulting in faster cutting. We have already seen it on the machine. We can sense it that it's much faster than the previous engines. So basically, unified engine currently is available. It's under the beta option. Anybody wanting to work with it can switch on the beta option, and it'll be available to them to check and test. The conditions, I've told you, if it's an old part with Turbo 3D HSM, only then you will see Turbo 3D HSM. If not, Turbo 3D HSM is gone forever. You'll not see Turbo 3D HSM at all. You'll only see the unified engine. This is only to make sure that people start using the unified engine. And if you ask me today, is it ready to replace HSM? I would say unified engine plus geodesic can replace HSM totally. You won't need HSM at all. It's completely ready to be replaced. Questions? No questions? I have a question. Myself. 1 minute, please. What is the future? Beyond the unified engine, what is the future? Okay, we are working on a very, very complex topic of Toolpath Editor. Probably early next year, we should have our own Toolpath Editor capable of doing toolpath editing on all 3-axis toolpaths, whether it is HSM, Turbo HSM, whether it is HSS, geodesic, anything. We should be able to do exactly the same kind of toolpath editing functions that you see with our competitors, probably better, because we are going to erase their mistakes, not take the same path of what they have done, but we are going to chart our own course. We already have some kind of a conceptual product ready, but there's no GUI at the moment, so we are working on the GUI, and probably by end of this year, we'll have something to play around with, and I would be inviting you all to also start working with the toolpath editing functions and giving us feedback on the same. Thank you.